Hey guys, it's your Perdiguerra of 11 Newton and welcome back to the channel. Today we're going to study the difference between function values and limits. I'm actually not going to teach much. I'll leave that on my partner, Luigi, to get away.
Hi everyone, I'm Luigi Geronimo of 11 Newton, and we are going to teach you the difference of the limit of f of x as x approaches 3 and f of c. In calculus, we learn that functions have distinct behaviors on a given particular input. That is why we find this limit using the formula limit of f of x as x approaches c is equal to L, where c is a constant and L is the limit. Function values, on the other hand, are values wherein any given x has a specific value of y. For instance, if we are to find the f of x of 2x, where x is equal to 3, we will just substitute x with 3 and multiply it by 2, giving you the product of 6. But still, some are confused between the two. So, in this topic, we will answer the question if the limit of f of x as x approaches c is always equal to f of c. So let's start determining the difference of the limit of f of x as x approaches c and f of c. Let's show the picture of the graph. We will examine the graph in stages. Let's start when x is equal to 1. So what is f1? In order to do this, we need to go to an x value of 1 along with the x-axis and go vertically until you hit the graph. Then go across to find the corresponding y value. If we do this in the graph, we see that f of 1 is equal to 2. Now suppose that we need to find the limit of f of x as x approaches 1 from the left. In other words, if we were to approach an x value of 1 from the left, or numbers smaller than 1, what would the y value approach? Examining the graph, we see that the limit of f of x as x approaches 1 from the left is equal to 0. Next, suppose we need to find the limit of f of x as x approaches 1 from the right. In other words, if we were to approach a value of x that is 1 from the right, or numbers bigger than 1, what would the y value approach? Once again, examining the graph, we see that the limit of f of x as x approaches 1 from the right is equal to 2. In situations like this, where the limit from the left does not equal the limit from the right, we say that the limit of f of x as x approaches 1 does not exist. Note here that f of 1 is equal to 2, but the limit of f of x as x approaches 1 does not exist. Now let's move on when x is equal to 2. Examining the graph and using the same methods as above, we can say that f of 2 is equal to 3. The limit of f of x as x approaches 2 from the left is equal to 2, and the limit of f of x as x approaches 2 from the right is equal to 2. In this situation, we see that the limit from the left equals the limit from the right. We can therefore say that the limit of f of x as x approaches 2 is equal to 2. But notice that the limit of f of x as x approaches 2 is not equal to f of 2. The last example that I'm going to give you, when x is equal to 3. Examining the graph, we see f of 3 is equal to 4, the limit of f of x as x approaches 3 from the left is equal to 4, and the limit of f of x as x approaches 3 from the right is equal to 4. In this situation, we see that the limit from the left equals the limit from the right. We can therefore say that the limit of f of x as x approaches 3 is equal to 4. Now, notice that f of 3 is equal to the limit of f of x as x approaches 3. In situations like this, where the limit of f of x is as x approaches a is equal to f of a, we say that f of x is continuous at x is equal to a. Thank you for watching this video, and I hope that you learned a lot and you enjoyed watching it. But before we end this video, I will leave you a quotable quote. The only way to learn mathematics is to do mathematics. That's it. I'm Luigi Geronimo, and I'm out.